Good afternoon, everyone, and welcome to NYSERDA's fourth public webinar on the preparation of a feasibility study to explore the potential of wind energy generation on the Great Lakes of New York State. I'm Cheryl Huber with NYSERDA and will be leading us through today's presentation once again. This is the fourth of four presentations that NYSERDA will be hosting this year on the process of conducting this feasibility study. Today, we are pleased to be joined by the study's principal investigators once again as they present their topics in greater detail. This includes preliminary findings in their research that will inform the science-based conclusions that will comprise the written Great Lakes Wind Feasibility Study. The study is being authored by three contracted teams: the National Renewable Energy Laboratory, or UNREL, Advizian, and Terra Consulting, and we will hear from them today. Next slide, please. But before we begin, I would like to mention a few points of webinar logistics. Today's webinar is being recorded. All attendees will be muted for the duration of the webinar. You may submit a question for the question and answer portion of today's webinar via the Q&A feature at any point during the presentation. The chat is disabled, but you will be able to communicate with the study team via the Q&A. This slide deck and recording will be posted to NYSERDA's Great Lakes Wind website, where you can find additional resources that include materials from the three earlier webinars presented this year. Those were held in March, May, and August, as well as the recording and report out of the public feedback session that took place in June of this year. Next slide, please. Oh, I'm sorry, and if any technical problems should arise, please contact Sal Graven at the email address found there at the bottom of the slide. Thank you. Next slide, please. This is the correct one. The agenda for today's webinar has a similar cadence as those presented this year, covering the multitude of topics contained in the study and of interest to stakeholders. As we do at the start of each webinar in this series, NYSERDA will first provide a brief overview of the feasibility study. Next, we will hear from each research team as subject matter experts on these related topics. We will hear from UNREL first on lake resource characterization, port infrastructure, technology best suited to these conditions, cost analysis, and an overview of economic development opportunities related to potential Great Lakes wind projects. Advizian will then provide an overview of regulatory processes needed to permit energy projects in the lake, a risk-benefit mitigation analysis that will cover various topics, including environmental conditions and sensitivities, and a visualization study to address potential viewshed impacts. We will hear from Terra Consulting after that on joint work with the Brattle Group on how energy will get to shore in their grid interconnection analysis. Finally, NYSERDA will provide an overview of stakeholder outreach that has occurred during the course of the past 9 months and close out the presentation with the remaining timeline for the submission of the feasibility study to the New York Public Service Commission. We will conclude with a Q&A session where you will be able to ask questions to NYSERDA and members of these research teams. Next slide, please. So during today's presentation, we aim to revisit the order to conduct this feasibility study. It's a good basis for the start of all of these webinars and how we have begun each one. We would also like to provide an update on the study research that's in progress as we near the end of 2021. This information will also build on the three previous webinars that have occurred this year. We plan to provide an overview of NYSERDA's outreach efforts this year as well, and an overview of the next steps for the study and ways for continued stakeholder involvement. Next slide, please. The scope of this study includes Lake Erie and Lake Ontario and the New York shoreline along these two lakes. This map is a regional snapshot that shows boundaries of the study scope and the multiple jurisdictions of state, federal, international, and tribal entities with interest in this geographic area. It also shows physical characteristics of the lakes, including the depth contours of each lake and the 4 Great Lakes watershed basins in the region. Next slide, please. New York State has a clean energy standard that is designed to fight climate change, reduce harmful air pollution, and ensure a diverse and reliable low-carbon energy supply. Under the state's nation-leading climate legislation, the Climate Act of 2019, The state's clean energy standard was expanded to require 70% of New York's electricity come from renewable energy sources, such as solar and wind, by the year 2030. In October 15th of last year, the Public Service Commission adopted an order to further expand the state's clean energy standard, including an instruction to NYSERDA to conduct a feasibility study of potential Great Lakes wind energy in order to assess the overall value and viability of this potential resource. The study is to consider the environmental, maritime, economic, and social issues, as well as market barriers and costs of developing wind in the Great Lakes. The Commission directed NYSERDA to commence this study within 180 days of the effective date of the order and to be completed with a total budget of $1 million. The study began in February of 2021 and will take approximately 1 year for completion, which is currently scheduled for submission to the Public Service Commission in the first quarter of 2022. Next slide, please. The Great Lakes Wind Feasibility Study is just one part of a bigger process. The study is not a planning document. Rather, it's a non-directional information collecting exercise based in sound science that will inform the state if or how it should consider Great Lakes wind as a potential renewable energy source for New Yorkers. This study does not collect new data. Rather, the methodologies model and analyze existing data sources in new or different ways than compared to earlier studies in the published scientific literature. Once the study is delivered to NYSERDA by the research team, as shown here, we will then submit the final study and likely policy recommendations to the New York State Public Service Commission. The Public Service Commission will then decide next steps, which can range from no further action at this time, consider Great Lakes wind in the future, address existing data gaps, commission a small pilot project, or even direct a procurement of actual wind projects, or any variation in between. Public input is an important part of each of these steps, and NYSERDA has included these quarterly webinar updates and a discrete public feedback session throughout the study process in order to ensure that sharing of information. Additional actions by the Public Service Commission will include formal public comment per the appropriate regulatory processes. Next slide, please. I am pleased now to introduce Walter Musil of the National Renewable Energy Laboratory, or NREL, to describe his team and their components of the feasibility study. Over to you, Walt.
Thank you, Cheryl. I think I have my camera on now. Could you, let's go to the first slide. And I just want to start by thanking NYSERDA and for selecting us to be part of this team and for leading this great team which is comprised of Advician and Patera Brattle Group. NREL is the coordinator of this group, and this is the team at NREL that's shown in this first slide. I'm pleased to be the one of the co-principal investigators, along with my colleague Rebecca Green, who you see picture here, and she's on the line too to help answer questions as well. And you see this other team, which other members of our team, which are involved in the economic analysis and job and economic impacts analysis, and looking at a lot of the physical characteristics of the lake, which I'm going to talk about. So let's move to the next slide. And I'm pleased to say that we have new wind resource data for the Great Lakes that's replacing some of the old data sets as the technology advances. We now have a 21-year record using ensemble based analysis and an advanced weather research forecasting model that comes from the National Center for Atmospheric Research. And we have plotted that data on this map here, so you can see that it has very little variability. We have wind speeds averaging between 8.5 and 9 meters per second across the New York side of the lakes. And you see these color gradients on the heat map show very little variability. These are 1/10 of a meter increments. So in the areas where wind projects might go, that we're up in the high 8 to 9 meters per second wind speeds. And so we will be able to provide this data to anyone who wants it, and you can do your own investigations on what this means. But this is a good result. On the next slide, I want to talk more about how we looked at the physical characteristics. Now, this map just shows the grid of how we broke the lakes down into little cells. These big red squares are 15 minute by 15 minute on the longitude latitude grid. And then inside of each of those red blocks, there's these blue blocks that you can barely see. And they're, so there's 15 by 15 of those inside of each of those squares. And those are the cells that we use to evaluate various physical characteristics. Now, next slide. So the physical characteristics that, at least there's a lot of them, but we'll report on these here in this plot here. We looked at water depth, ice duration, soil type, and sediment depth, and these are plotted on the bar charts below. And one of these charts is for Lake Erie on the left, and the other is for Lake Ontario on the right. And you can see that they're divided according to distance from shore along the x-axis, the horizontal axis. So as you get further from shore, there's less area, and that's the dimension plotted on the vertical axis. And so this is just quantifying what the soil types, water depths, ice durations, and sediment depths are for each of the lakes according to those distances. And you can see, of course, the area gets smaller as you get further from shore. And that's because in some analysis, there will be some decisions made about what the proper distances are from shore. And these are important parameters because water depth determines the type of technology. Ice duration really determines some of the loading, not all of it. We think that a lot of the loading, most of the loading comes from the aerodynamics and the hydrodynamics of the water on the structures, but ice is going to be a factor. Soil type will determine some of what the limitations are for some of the foundations, and sediment depth determines if you can drive piles very deep or not, and that will also determine some of the foundation types, like for instance monopiles that are used in other places. They may not be able to use in some places in the lakes. So next slide. This is an example of the maps on the right show the distance or the depth of the soil that's on top of the bedrock. So that's important because the soil that's on top of the bedrock is what holds the foundations in place, and you can't drive piles deeper than where the bedrock is. And we found that in Lake Erie, the average was about 100 feet of depth, which may enable some pile driving in some of these foundation types to be used. We found that the soil types were softer clays. They may limit the use of monopiles because they're soft, but there's definitely quite a few different foundation types that would be available. Lake Erie has much greater ice coverage than Lake Ontario because it's shallower and it freezes faster. So ice flows will be a bigger factor in Lake Erie, and those are being considered. They have substructure types, all the substructure types that have been used in Europe to resist ice flows in the Baltic Sea, for example, use these ice cones that deflect the ice and break up the ice as it flows past. So that's the type of technology that would be used. In Ontario, it would be the same thing, but less important, but still very important that the ice is considered. We found that the average depth of the bedrock is shallower. It's about 75 feet in depth, which means that there wouldn't be as much soil to grab onto, but in Lake Ontario, it's going to be floating structures. So anchor type it would be anchors, and anchors don't need as deep of a thickness of soil to grab onto. So there should be no problem anchoring in Lake Ontario. We found that there's a small percentage. This is some analysis that Vizian had done, and these maps show the differences. The small percentage vary containing this rocky glacial deposits, which may, some developers, if they were working there, might have to avoid that. So next slide. So that a lot of that background is what we use to look at what is required for ports. So some of the high level conclusions are, and I said this, Lake Erie is going to be fixed bottom substructures because the water's shallower. That means that we're going to need heavy lift vessels to go out onto the lake to install the wind turbines. And those heavy lift vessels that are normally used in the Atlantic and out in the ocean can't get through the locks. So they'll have to be probably smaller turbines that can use systems that are installed and that live on the lakes. And there's a lot of new technologies that we might be able to use as well. On Lake Ontario, offshore wind turbines will probably be floating wind turbines because the water is deeper. And that means that the turbines will probably be assembled in a port facility yet to be named, but the heavy lift requirements will still be there, and those cranes will have to be at the port facility. Next slide, please. So from a turbine selection standpoint, there's a lot of options, but we picked one just to use as an example, in this GE Cypress 6 megawatt turbine, which has 164 meter diameter, was selected so we could do the analysis. It has the capability of providing about 2,800, the amount of energy used by 2,800 New York homes. One turbine can do that if it's properly placed on the lake. And so we'll be using that as our kind of our reference turbine, although there are a lot of different turbines of that size. It's a land-based turbine. Land-based systems are starting to be mass produced and at a larger scale, and it fits very well into what we want to do. In Lake Ontario, the floating turbines are only size limited by the crane capacity at the port. In Lake Erie, they're size limited by the crane capacity of the vessel that can be on the lake. Next slide. So in Lake Erie, here's an example. This barge shown on the right side is a barge that is made out of modular, smaller barges that were bolted together, and they called it the soccer pitch barge because it's the size of half of a soccer pitch. But it's made up of smaller barges, and then a larger crane was moved onto it. So this big crane can install the bigger machines, and there's no the limit of the machine size is based on the limit of this crane capacity. So we looked at 3 deployment scenarios. U.S. flag vessels, which are compliant with the Jones Act, which would be something like this vessel shown. Non-compliant or non-U.S. vessels, just to see what that would look like. That would probably be something from the Canadian side, or float out substructures that are being developed. And there's a lot of promising new technology that's being developed that would avoid the heavy lift cranes altogether. So we're looking at that. Next slide. I don't have a slide similar to for Lake Ontario, but the port in Lake Ontario would have the heavy lift capacity of the crane that was just shown, but it would be at the port side. So these are the ports that we looked at. There's 4 possibilities on Lake Ontario and 3 on Lake Erie. And we looked at key capabilities: channel depth, crane capacity, quayside space, and air draft. That air draft means how much clearance is there between the water and what's above it. So if there's a big bridge, the port was ruled out because you can't tow the wind turbines fully assembled underneath that bridge. So you see that there's one port, Oswego, that that can be modified, and that's possible to be modified in Ontario. And then in Lake Erie, there's a couple that could be modified to support offshore or lakeside wind development. And so the red boxes are kind of exclude that port, and the others mean that there would need to be some upgrades, or they're already capable. Next slide. I'm going to get into some substructure types now. So these figures are more conventional substructure types that are available right now. And looking through, for fixed bottom substructures on Lake Erie, you need a slender substructure at the water line to avoid high ice loading. So some of these might not work. Some of them are questionable. But a jacket, for example, like the ones in Block Island, probably would need to be modified differently so that the ice wouldn't jam up inside of the substructures, and that's why that's X'd out. So that's an example of what we're looking at, but there's a lot of new technologies that could be customized for the lake and that are being developed right now that could support fixed bottom substructures in Lake Erie. Next slide. The floating substructures are different. They're carrying their load through the mooring system and through the anchors. And so when the ice moves across the lake, you also need a slender substructure. And so this conventional drawing that I had in here, most of these barges, semi-submersibles, which are very common in the ocean, certain hybrids and spars, they wouldn't work. Spars won't work because of the deep draft. Now they could be modified so that the drafts, there's hybrid types that can be modified. The tension leg platform with the slender column penetrating the waterline is the only one of this drawing, but there's a lot of other types that are in the works that would be customized for the lake, and that's what this really the bottom bullet here. Many substructure types are feasible, but there's going to be customization for the lake in order to achieve floating substructures that will work. And so there's a lot of promising technologies there. We didn't find any anchor types that wouldn't work. All the anchor types are feasible depending on the application and where you're doing it in the soils. Next slide, please. So moving to the economic analysis and what we're doing, we've kind of narrowed down some of the assumptions of what we would do in the lake. Slightly smaller turbines we're looking at, although I said that maybe these turbines could be, they're really limited by the capacity of the crane that you can get onto the lake. So we're assuming 6 megawatt turbines. We're assuming a project size of about 600 megawatts, which means that each project would have 100 wind turbines spaced at 7 diameters. The location of those projects haven't been determined yet, but we will need port upgrades and access. Those costs are not part of the project, and the assumption is that those upgrades would be done and that those ports would be available. The land-based grid connections are also assumed to be available, and Rick's going to talk about that in a minute. The distance to the installation and service ports will be calculated exactly to where we think the most likely port would be, and the workforce and supply chain is assumed to be available for the projects. We're not going to have to invest in training people, that they would already be trained. The financing is going to be based on projects that have typical projects that have already been developed for offshore wind in the Atlantic and other places. And we made no judgments about where projects could go or where they could not go. That's left for a later exercise. So we'll be doing scenario development in the economics. Then models, we have 2 models, Orbit and Orca, to do and we'll be customizing those for the specific conditions of the lakes, and then running our cost and sensitivity studies for both the geospatial analysis and the temporal, the time-dependent parameters out past 2030 in terms of development, so we can get an idea of what the costs would be on the lakes, on both lakes, and they'll rerun for both lakes with different assumptions floating on Ontario, fixed on Lake Erie. Next slide, please. And this is my last slide. We're going to be doing a jobs and economic development analysis using NREL's jobs and economic development impact model called JEDI. The results of this model will calculate the actual jobs created by projects on the lake and the local revenues that impact those jobs, that people, and then the induced impacts, like people going to restaurants that work on the projects, or moving in and out of the area because of the opportunities offered by the development. And then we'll be looking at the workforce and what the existing workforce looks like, and what the programs that are in the region look like to help train those workers. So that's the end of my talk, and I'll pass it on now to Advisian.
Hello, everyone. Thank you. Thank you, Walt. Hello, I'll be presenting for our Advisian team. Next slide, please. Our Advisian team is Dr. Sarah Corbis, the project manager, Dr. John Brand, the geosciences lead, and myself, Katie White, the fisheries lead. Next slide, please. The Advisian team is working on 3 aspects of the NYSERDA Great Lakes Wind feasibility study, and that is the state and federal permitting study, the geophysical and geohazard study, and the relative risk minimization and mitigation and benefits study. Next slide, please. We are now in the final stages of our state and federal permitting study. This is a draft example for illustration purposes. We are still integrating and finalizing our end product, but it will be in the format similar to this. We have developed one scenario for utility scale and one scenario for demonstration scale, since they have a difference in permitting process. We developed cross-functional process flow charts for the overall permitting process, and this shows activities of the developer and all federal and state regulators. It shows handoffs between agencies and actors, and opportunities for public comment and public announcements, and it visualizes triggers, decision points, and information flows between the process. Next slide, please. This is our relative risk minimization, mitigations, and benefits study for the Great Lakes Wind. Here's our updated pre-construction, construction, and post-construction stressors. It is important to differentiate a stressor from a potential impact. Different impacts can result due to the same stressor. For example, the post-construction stressor of long-term structures that could result in displacement of certain avian species, and also could create new marine habitat and attract local prey for marine species. It is important to understand that pre-construction and construction stressors are short-term and post-construction stressors are long-term. Here we also have our updated receptor group list. We separated out birds into 4 categories: shorebirds, waterfowl, land birds, and gulls and terns. We have also used different onshore and offshore habitat preferences to indicate where receptor groups could be in the onshore and offshore environment. Next slide, please. From the synthesized literature, this map represents where birds most likely do occur. Green is waterfowl, blue is gulls and terns, ospreys and eagles, and purple is land birds, shorebirds, and raptors. This represents where birds forage, but does not represent a cross-lake migration path. The two main potential impacts of Great Lakes wind to birds is displacement and collision, which are post-construction stressors and long-term. There are data gaps currently that limit the understanding of how birds fly in the offshore space, such as flight altitude, paths, and weather pattern triggers. Next slide, please. From the synthesized literature, this map represents where invertebrates most likely occur. Orange is shallow invertebrates, less than 30 meters depth. Blue is intermediate invertebrates, between 30 and 90 meters depth. And yellow is deep invertebrates, between 90 and 130 meters depth. An example of potential impacts from Great Lakes wind to invertebrates are bottom disturbance and habitat alteration, which are both construction stressors and short-term. This does not mean that typical shallow, intermediate, and deep water invertebrates cannot, be found occurring outside their typical range, but it does illustrate where they are most likely to occur. Next steps in our study are to integrate the findings from the summary characterization of New York's Great Lakes fisheries by New York State Department of Environmental Conservation. We are also synthesizing the public feedback session from NYSERDA, and we are conducting our final analysis of the interactions between stressors and receptor groups. Next slide, please. Our visibility impact assessments are hypothetical scenarios based on UNREL selection of base modeled turbines for use in the overall study. Feasibility study will present the range of opportunities and impacts. Distance from shore not only has aesthetic implications, it influences many of the risks and benefits in a substantive way. Building viewshed assessments at indicative distances from shore is part of the overall feasibility study. Distance from shore has other implications beyond number of impacted individuals and historical sites. For example, wind resources, build-out capacity, economic benefits, and wildlife use. Our viewshed assessment is a line of sight evaluation that considers the height of a turbine and the height of a bystander on land and where there is intervisibility. Next slide, please. Here's a hypothetical East Erie example. The view sheds for a hypothetical turbine are the location of the star. Colored areas are the land cover, usually vegetation related. Land cover gives us screening potential for future detailed assessment. The star represents one turbine. In this example of one turbine in Eastern Erie, the land cover in the zone of theoretical visibility is mainly medium to highly developed areas to the northeast and a combination of mixed vegetation areas to the south and southwest of the turbine. Next slide, please. In this hypothetical Ontario example, one turbine is in Central Lake Ontario, and the land cover in the zone of theoretical visibility is mixed vegetation areas directly south with medium and highly developed areas to the southwest of the one turbine. Next slide, please. Thank you for your time, and now on to Rick.
Thank you, Katie. So I'm here to present this afternoon the work of Pitera and Brattle together in looking at interconnecting the electrical output of Great Lakes wind to the existing land-based grid in New York. Next slide, please. So this is our study team. I'm Rick Austria, together with Hannes and Ramon. We are the ones conducting the feasibility assessment for interconnection to the land-based grid. Next slide, please. So in the previous webinar, the third one, we had talked about bracketing the general locations for where Great Lakes wind can interconnect to the land-based grid. We had 6 regions identified. These regions are defined by the characteristic of the land-based grid, where there are only certain locations to interconnect electrically to the existing facilities. Now, for each of these regions, we looked at specific points where an interconnection can actually take place, going from Great Lakes wind generation to the ports on land to the point of interconnection on the land-based grid. The measurement of capacity at this point is the next stage in the analysis. The capacity I'm talking about is also termed as headroom. Headroom represents how many megawatts can be interconnected to the land-based grid within the acceptable ranges for reliability and operations of the land-based grid. Next slide, please. So the analysis, which we refer to as headroom analysis, is based on a representation of the land-based grid. These are what we call power flow models. We have several models to consider. One set of models is based on the development by the New York Independent System Operator of representation of the grid for 2030, and these are filed with FERC as a statement of the model of the grid. So this is one of the set of models. The other model which we are presently developing is one where we represent renewable generation that may come into service in 2030, other assumptions, including the modeling of the Tier 4 awards. The Tier 4 awards from NYSERDA had 2 projects included, the Clean Path New York, or CPNY, which you can see in the diagram on the right. It's a transmission line that connects the Fraser substation to the Rainey substation downstate in New York City. The other component of the Tier 4 award is the Champlain Hudson Power Express, the CHPE line, which is showed on the right side of the diagram. It goes from Hydro-Quebec to Astoria in New York. For the purposes of Great Lakes wind interconnection, we are only considering Clean Path New York, which will have a direct impact on the generation that's going to come from Great Lakes wind, since this is going to require delivery at the Fraser substation, will have an impact on this. Next slide, please. The calculation of headroom is based on a methodology that's recommended by the Department of Public Service for New York. There's a capacity headroom calculation and an energy headroom calculation. For the purposes of this feasibility study, we are looking at the capacity headroom methodology, which determines the megawatts that can be interconnected to the existing land-based grid, or the 2030 land-based grid. There are 2 types of headroom megawatts that will be calculated in this study. One is what we call the solo injection headroom. And this one measures how many megawatts of Great Lakes wind can be interconnected at any single point or location on the land-based grid, assuming there are no other Great Lakes wind interconnections. The idea to this analysis is to determine, if we select one site, what is the maximum number of megawatts of Great Lakes wind that can be interconnected at that site. The second level of analysis is what we call the simultaneous headroom. So in this analysis, we would look at multiple potential interconnection sites for Great Lakes wind. We may have interconnection coming from Erie Lake wind generation, as well as from Ontario Lake. And the idea in this analysis is to determine, with the combination of interconnections from the various wind generation coming into the land-based grid, what is the maximum that the grid can accept within the headroom limits. So these are analyses that are ongoing, which will be part of the final report for this study. Next slide, please. And with that, I thank you for your time. I will now turn this over to Cheryl. Thank you.
Thank you, Rick, and thank you to all of our presenters today for this informational overview of the study components as they stand to date. Next slide, please. So throughout the course of this year, NYSERDA has prioritized outreach to the public and regional stakeholders in the New York Great Lakes area. During the creation of this feasibility study, NYSERDA hosted these 4 informational webinars to provide as much information to the public as possible. This has enabled stakeholders to input valuable knowledge at every step of the feasibility study. In lieu of in-person meetings associated with the uncertainties of COVID-19, we also dedicated time this year for a virtual public feedback session where we were able to hear direct comments from all interested parties who were able to attend. We also provided the opportunity for 1 week afterward for written comments for those who were unable to attend that virtual meeting, which was held in the evening. NYSERDA has also communicated with surrounding states, countries, and tribal nations throughout the course of this year. In this time, we've incorporated many of the topics of concerns and interest into the study early on, including those related to wildlife, visibility, pollution and contamination considerations, economic opportunities, climate change concerns, and the state's renewable energy policies, just to name a few. After hearing from you that we should extend our outreach beyond our robust electronic and communication strategy that exists, NYSERDA is currently running print ads in the New York counties surrounding the Great Lakes. There's an example of the ad shown here, which has been and will continue to be seen by members of the public who do not have reliable internet or email access. And this also provides an alternative engagement opportunity to ensure all members of the public can weigh in on the study. Next slide, please. The remaining timeline for the completion of the study is mapped out here. NYSERDA is currently reviewing all of the work that has been done as we work toward the draft version of this study being written this fall. Early next year, the final study will be submitted per the Public Service Commission order, along with any supporting materials, including the report out from the virtual public feedback session, other appended studies that were part of this, the investigation of this study that have been presented here. And all of these supporting materials will help assist in future policy decisions. Based on the findings of the study, the Public Service Commission, through its processes, will conclude if Great Lakes Wind is a feasible addition to the state's renewable energy portfolio, likely in 2022. NYSERDA will provide support in those processes to ensure input received from stakeholders to date is included in those decisions, as I've already mentioned. Next slide, please. There are multiple ways stakeholders can stay engaged as we work toward the study's submission to the Public Service Commission early next year. Please continue to utilize the email address and website to communicate with NYSERDA. The best way to do that is to sign up to receive email updates on future webinars, meetings, and materials related to the feasibility study as they become available. Please visit the Great Lakes Wind website to access this feature, as well as the other presentations and recordings from the 4 informational webinars that were held this year, as well as the public feedback session hosted by NYSERDA. Next slide, please. And with that, we have reached the conclusion of today's presentation. We will take remaining time to answer your questions. As a reminder, if you would like to submit a question, please use the Q&A feature found on your screen now to submit your question. Also found here on this slide is the email address that I referenced earlier on, greatlakeswind@nycerta.ny.gov, as the primary way that folks can communicate with NYCERTA and the study team. So with that, I'm going to turn over to some Q&A. There was one comment here, folks wondering if they would be able to turn on their microphone and talk. And the answer to that is that you can submit your questions via the Q&A feature right now. If you have future questions or comments that you would like to provide, please use the email address that I just noted, greatlakeswind@nycerta.ny.gov. So let's see if what other questions have come in here. Okay. So will a return on investment also be considered to include the cost of installation, profits from projects, value of carbon offsets, and opportunity costs? So from NYCERTA's point of view, I can answer that the feasibility study represents information relevant to the return on investment, but will not determine an appropriate return. NYCERTA may elect to consider that in its filing with DPS. So that is to be seen. Consistent with its approach to evaluating clean energy resources under the Clean Energy Standard, the Public Service Commission consistently evaluates cost benefits associated with carbon mitigation and health benefits of potential clean energy resources in its consideration of the value of renewable energy credits, or RECs. That answered that question related to that. Another question came in. This one is more on the technical side. And Walt, if you don't mind unmuting yourself, I'm going to ask this one of you. Feasibility studies should include a consideration of how large a project must be. In this case, how many turbines and total rated capacity. Has such an assessment been made, or will it be made as part of the final report? And I know this is something that you touched on one of your slides as far as an indicative project size. So maybe if there's any further information that you can provide, we would appreciate hearing that.
Sure. So the indicative size was 600 megawatts, and of course, these will be privately developed projects if they occur, and so we don't know the exact size. They could range, they could have a wide range. 600 megawatts is typical of a project size of what's being built in other places right now in offshore wind. And so when we do the economic analysis, we wanted to choose a project that was large enough to get the benefits of commercial scale. And so 600 megawatts gets you to that point. The Vineyard Wind project, for example, which is being developed in Massachusetts, is 800 megawatts. So this is a little smaller. The turbines are a little smaller than those. We chose that because it had a kind of a footprint that I think represents what might be built. There needs to be a scale large enough so that you can amortize a lot of the investments associated with cables to shore and things like that. So the scale needs to be large enough to gain those economies of scale, and that's why we chose that. I'd be happy to answer any further questions on that.
Thank you. Okay, I'm going to move to another question here. Does any part of the feasibility study or other ongoing study we are aware of address the question of whether wind power assets should be publicly or privately owned? I will say that this feasibility study does not anticipate state-owned and operated wind generation assets, but assumes projects will be developed, owned, and operated by private entities, potentially with financial support from the state in the form of those renewable energy credits or RECs, incentives or grants or other mechanisms. And an example of that is the Department of Energy's investment in the Icebreaker Wind project off the coast of Ohio. And so it's possible, but I think that for the purposes of this study, the assumptions are being made that there will be private ownership or of development of any potential project that may or may not be recommended. So I hope that helped to answer that question. Going to turn now to another question. It's an environmental question that I'm hoping Katie can help us out with. It has to do with birds and the receptor stressor classification or designation of that was conducted during your investigation. So it's specifically related to raptors and how they were not identified as a receptor group as presented. And this comment here is that the eastern shore of Lake Ontario is a major raptor flyway for raptors and other species. Is there any insights or additional color that you can provide on that either geographic region of Lake Ontario or specifically about raptors in the information that you found?
Definitely. Eastern Ontario is definitely seen for many species as a high area of occurrence and abundance and density. And we separated out into the four categories that we had specifically to really identify how different types of birds and groups would be using the space and flying and foraging and offshore. We do indicate that specifically that part of Eastern Ontario is a high area of abundance for different species, but raptors were grouped into a different part. And I think I would have to wait for our bird specialist, who is not on the phone at the moment, to talk about that a little bit further. But yes, that is taken into account into our analysis of that area of the coastal region of Ontario and why that is so important for different bird species.
Thanks, that's really great. And while I have you, Katie, another question on wildlife has come in. It's not specifically about resource characterization, but perhaps the economic impact on and costs on tourism related to recreational fishing. And so while that is a different aspect of the study, I would like to just talk about or ask you more about the fishing data that is going into the part of the study that you're working on. I know that is certainly considered, and you addressed some resources from the New York State Department of Environmental Conservation that are currently being reviewed on data related to that. Is there anything else that you can add related to types of fish that are high recreational species or their temperature preferences or anything like that that might help to address how recreational fishing is considered in the context of the study?
Yes, fisheries are a very unique and complex situation in the Great Lakes, and some species that are high value and high targeted follow the thermocline. And so it's different every day in a different place. And so there's a lot of different variables to try to focus and pinpoint where different species could predictably be. We also do have a little bit of a limitation with understanding exactly what grounds are used in what areas. But the New York State Department of Environmental Conservation has been very, very helpful with especially trying to show what areas of the lake are used for which target fishery. So we are taking that into account. And yes, recreational fishing and commercial fishing are both very important to these two lakes.
Thank you. Appreciate that. Move on to another question here. Can you discuss a bit about the engagement with tribal nations, concerns, opinions, etc.? Sure. So I will say that NYSERDA had presented the feasibility study and pretty much a lot of the information that you saw here from NYSERDA's perspective about where the study came from and why we're doing this during the Haudenosaunee Environmental Task Force meeting back in, I believe it was September's meeting. And at that time, we had a conversation, a discussion based on points of interest and other resources of interest to the tribal nations in the area. And there was a lot of talk about resources that are currently used for food, as well as the ensuring that clean water and clean food are available to those communities. And so there was a lot of just information sharing back and forth in that regard, and we continue those discussions with them as the study comes forth. We share information like these webinars, and other aspects of the study that we would like particularly feedback from those interested people. And that is true too for any government or nation that expresses interest in any part of this study. And so we're continuing those dialogues and continuing to share that information as it becomes available. If there's additional questions related to that, I'm always happy to help answer some more. So another question here is, what measures will be taken to work with labor unions to train and expand the local workforce? Again, I'll state that this is a feasibility study to understand the potential contribution of Great Lakes wind as a resource to support the state's ambitious clean energy goals. Specific measures to develop projects are not being developed right now through this study, as we've explained here. But we're actively assessing the potential economic development opportunities, including those workforce and job creation opportunities associated with the development of Great Lakes wind. And so that's not a wait and see, but as this this information matures and as the potential for these types of projects evolves, that sort of information and discussions will become available. So I think we have time for about one more question here. And I will say that if your question was not answered during the course of this webinar, please be assured that it has been recorded and that we will address it in one way or another. And you can always communicate those questions either now or future questions that might arise via the Great Lakes Wind email address that I shared, greatlateswind@nycerta.ny.gov. Excuse me. The final question here is that someone was interested in knowing about the affiliations of the study members. And as we stated throughout this webinar series and in the third public webinar, all of the study team members have been identified in their opening slides of each one of their sections and have their associated email addresses posted there as well. So if anyone has additional questions, please go ahead and feel free to reach out to folks and also do your own research to understand what publicly available credentials are out there. And with that, we're at the top of our hour here. I want to thank all of our presenters once again for participating in all 4 of these webinars, including today's. Again, please stay in touch with NYCERTA, and as more information becomes available, we are very happy to share that with folks. Thank you very much for joining today. Have a great afternoon.